Hey Alex, so I guess the analogy I give my kids to think about is I think about a wire is like a road. The battery it gives energy to charge, right? The charge is like a car traveling on the road, but instead of energy, you can think about the battery gives each car money, right? So the cars get money from the battery. They go through on the road. Here, it's free to drive, so they don't have to spend any money. When they get to a light bulb, a resistor, they have to spend some of their money, which is really energy, right? They give that energy up to the light bulb in the form of light. Traveling through the light bulb, they lose some energy. So let's say this is a 10-volt battery. Then that means they have 10 volts. They will use all of it going through both light bulbs. So since they are the same light bulbs, that means they have the same resistance. That means the toll is the same. So if it's a 10-volt battery, then the charge has 10 volts. It'll lose 5 volts here and 5 volts here. Looking at this situation, here's the same battery, so it's a 10-volt battery. The charge that flows here will have to lose 10 volts. But remember, a charge that goes this way will not be able to go this way. So both charges going through this circuit will lose 10 volts of energy, or will pay $10 to go through. So how does the potential at A, B, and C compare? Before A, it has the $10, and at C, it's got $5. And at B, well, at B, it's spending the money. So you can talk about it's somewhere between 10 and 5. How do the flow rates in X, Y, and Z compare to each other? Well, if you think about it, this is a road, right? All the cars, all the charges have to travel on this part of the road. So this has maximum flow rate, and then the flow rate splits. Some of the cars go this path, some of the cars will go this path, right? And again, cars are charges. So the charges that go this path are going to be fewer than the charges that go this path. That's because this resistor is harder to get through. It's a long bulb which has a higher resistance, and so even though it will lose 10 volts in both resistors, it's much harder to get through this. Maybe the toll booth's bumpy, the road's messed up, so more people or more charges will go through this resistance. So the flow rate at Z in this branch will be less than the flow rate in Y. If both resistors were R or both resistors were L, in other words the same, the flow rate in L and R, or in this branch and this branch, would be the same, and they would be equal to half of the flow rate at X. As it is now, this flow rate is going to be something more than 1/2 of X, and this flow rate will be something less than 1/2 of X. And then how does the potential at X, Y, and Z compare? Well, here it hasn't spent any of its money yet, so it's 10. Here it's 10, and here it's 10. So, and of course, obviously, if I were here or here, what would the voltage be? Well, it'd be 0, because you would have spent your money at the light bulb toll booths. Okay? Hope that makes sense. Email me if you have any more questions.